If you look at the night sky, you'll see a lot of objects. Most people think they are looking at stars, which of course isn't entirely false, but in the best sky conditions, the naked eye can see objects within an apparent magnitude of 8.0. This reveals about 43,197 objects in the night sky. There are also 9 galaxies visible to the naked eye that you might see when observing the sky, and there are about 13 nebulae that you might see. It is very difficult to distinguish between stars and galaxies by naked eye, and sometimes it's even difficult to distinguish using telescopes. Astronomers have observed one such galaxy recently. The stars in the galaxy are so immensely packed together that it looks like you are looking at a single star instead of a galaxy. These are galaxies that most people have never heard of before, mostly because they are extremely rare and also because they were only discovered recently. In this video, we are going to discuss about what this object exactly is, and we'll try to understand how the stars in this type of galaxies can stay so closely compacted together. But before we dive into the heart of these enigmatic cosmic wonders, let's first paint a vivid picture. Take a moment to gaze at M60 UCD1, situated approximately 54 million light-years away from our beloved Earth. M60 UCD1 is an ultra-compact dwarf galaxy. In terms of the actual size, the radius of this galaxy is approximately 80 light-years. Just to give you a comparison, the Milky Way galaxy is over 50,000 light-years in radius. So here we are talking about something that's basically at least 1,000 times smaller. Yet, it seems to contain a huge number of stars inside. In this case, over 200 million, possibly even more, making this type of galaxies literally the densest galaxies in the universe. It is just one example of the many peculiar galaxies we'll explore today. In a typical night sky visible to the naked eye, stars vastly outnumber the celestial objects. There are estimated to be around 100 to 400 billion stars in our Milky Way galaxy alone. When observing the night sky, you may see a few thousand stars, making up the overwhelming majority of visible objects. Galaxies, on the other hand, are much more distant and typically not individually visible without the aid of telescopes or binoculars. The number of galaxies visible to the naked eye is minimal, and they might appear as faint, fuzzy patches. In general, only a handful of galaxies, such as the Andromeda Galaxy, are visible without optical aid. To provide a rough estimate, the percentage of visible objects that are stars would be well above 99%, while galaxies visible to the naked eye would represent a tiny fraction, likely less than 0.001%. This is a generalization, and the actual percentages can vary based on specific conditions and individual observations. Back in 2015, 2 more galaxies surfaced, each boasting unusual spots, remarkably bright and distinct from other galaxies. These celestial anomalies were overlooked for years, dismissed by scientists using regular telescopes as mere bright stars. However, researchers employing advanced tools like the Hubble Space Telescope saw beyond, recognizing them as distant galaxies, waiting to reveal their secrets. Fast forward to the present, and recent studies have finally cracked the code, shedding light on the formation of these unique galaxies. In the vast expanse of the cosmos, dwarf galaxies come in various forms, some irregular, others elliptical, and even tiny spiral galaxies like NGC 5474. Yet recent years have unveiled a new category, ultra-diffuse galaxies, spread so thin they are barely visible. Though at first, some scientists thought that maybe these are just examples of large globular clusters. Turns out that in terms of dynamical and structural properties, they're extremely different from clusters and are definitely galaxies and nothing else. As we journey through space, we encounter galaxies like M85 HCC1, standing out as the densest galaxy ever identified. Its compact structure houses over 200 million stars within a radius of just over 50 light years. These galaxies, seemingly defying the norms, challenge our understanding of cosmic density. The intriguing part: by observing the center of these objects, researchers discovered a powerful X-ray emitting from within, basically suggesting that there's also a very powerful supermassive black hole, potentially at least 20 million solar masses in mass, or representing about 20% of the total mass of the entire galaxy. We find them not in isolation but nestled within massive galactic clusters like Virgo, Fornax cluster, or the Coma cluster. This discovery sparked a quest to unravel the mystery of their formation, survival, and the stars that inhabit them. Very weirdly, as we peer into the heart of these galaxies, we discovered this very common element: an exceptionally massive black hole. The question arises: how did these extreme conditions come to be, and how have they endured for billions of years? To answer these questions, scientists explored three propositions. Firstly, did they form alongside other galaxies during the early stages of the universe? Secondly, could they be the result of numerous globular clusters merging and forming a more dynamic entity? And thirdly, are they remnants of ancient galaxies transformed by interactions and with their colossal counterparts? To find answers, researchers turned their gaze to the Virgo cluster, conducting extensive observations. The result: over 100 dwarf galaxies in various stages of transition, showcasing the transformation from undisturbed dwarf galaxies to those undergoing tidal disruptions. As we navigate this cosmic metamorphosis, evidence emerges linking UCDs to the destruction of larger dwarf galaxies. The intricate dance of galactic evolution unfolds, offering a glimpse into the birth and evolution of these dense wonders. This phenomenon, witnessed predominantly in regions like Virgo, presents a puzzling contrast to our Milky Way, where similar observations yield globular clusters instead of UCDs. The challenge persists: what sets these regions apart? When the ages of these objects were calculated, all of them turned out to be pretty old, billions of years old, with some of them potentially being as old as the universe itself, almost 14 billion years old. In terms of actual density of stars, it seems to be at least several thousand times higher than our local neighborhood, basically where the solar system is. In other words, if we were to try to imagine the night skies in some of the star systems nearby, or better even, extremely close to the center where the black hole is, here's roughly what all this would look like. Basically, the densest night sky imaginable. The entire night skies here would be filled with various stars, with some stars only being thousands of astronomical units away from each other. To some extent, even forming huge multiple star systems with hundreds or thousands of stars, all technically part of the same system. Now, obviously, it's kind of impossible to imagine how all of this stays stable for so long, but somehow it seems to be possible. The stars here are definitely not colliding with anything, and this whole structure easily survived for billions of years. As all of these galaxies also contain a really massive black hole in the center, chances are we are going to be hearing more about them. As a lot of different scientists from various fields join in order to figure out what's happening here, how they're able to survive and exist, and what type of stars or potentially other objects exist inside of them. For the most part, this is still a relatively recent discovery, so there's still so much to learn, and we'll obviously come back and talk more about this once there are some more additional discoveries. As we continue our cosmic exploration, stay tuned for updates on the celestial enigmas. The studies providing a deeper dive into these discoveries are waiting for you in the description below.